Chapter 8 is all about right triangles. So we're going to start things off fairly simple with the Pythagorean Theorem. This is something you already know, but if you've got a right triangle, in this case triangle ABC, and we'll call the two legs A and B and the hypotenuse C, then A squared plus B squared equals C squared. I did pick a couple of harder example problems just because this is something we are so familiar with, so I figured we'd get a little challenge in the examples. So we're looking at a square that has an area of 2,500 square feet. Find the length of the diagonal. So I'm going to start by drawing out a picture of this. I've got a square. Since it's a square, I know it's got right angles, and I know all the sides are going to be the same. And I want to find the length of the diagonal, so I want to find the length of that line. This square has an area of 2,500 square feet. So we should start by finding the side lengths of the square. Well, we know that area is just length times width. In the case of a square, it'd just be one side times another side. So let's say the area is just S squared. So to figure out what one side is, I would just have to find the square root of 2,500. What multiplies by itself to be 2,500? That should be 50. All right, and now I want to find the length of the diagonal. So I'm looking at a triangle. Right here. I know that the two legs of it are both 50 feet, and I'm trying to find the length of the hypotenuse. So our Pythagorean theorem, A squared plus B squared equals C squared. In this case would be 50 squared plus 50 squared equals C squared, where C is our diagonal. Well, we already know 50 squared because we just took the square root of 2,500. And then to figure out my diagonal, I would just need to square root both sides. It does not tell us here if we want our answer in exact form or in a decimal approximation. Since it's the case of a real world problem, I would probably just throw it in a calculator and get a decimal approximation. So the square root of 5,000 should be about 70.7 feet. Let's just do a quick review though. If you did want to simplify that radical, we would pull out some perfect squares. So I know 100 goes in there for sure. 5,000 divided by 100, well, I'd just take a 0 off, so that would get me down to 50. And 50 would be 25 times 2. So I'll rewrite that as the square root of 100 times the square root of 25 times the square root of 2. Square root of 100 is 10. Square root of 25 is 5. Square root of 2 doesn't simplify, so that would be 50 roots of 2. And again, it doesn't say we need a decimal approximation or an exact answer. So you could either say 50 times the square root of 2, or you could say 7.7 feet. All right, in our next one, we're trying to find the area of this triangle. I noticed right away that this triangle is isosceles. So that means that the altitude will go through the midpoint of the base. So if the entire base of this triangle is 16 units, we know that each side of it is going to be 8. And then we'll kind of focus on the two right triangles that this isosceles triangle is being divided into. So let's look at this one on the right. It's got one leg that is h, that's the height. It's got one leg that is 8, and we know the hypotenuse is 10. So our Pythagorean theorem, a squared plus b squared equals c squared. In this specific case would be h squared plus 8 squared equals 10 squared. I know 8 squared is 64, 10 squared is 100. Subtract 64 on each side, and then take the square root of each side. So h is going to be 6. We're almost there. We were asked to find the height of this, or not the height, the area of this triangle. Area is 1/2 times base times height. You might have learned it as base times height divided by 2. That's the exact same thing. Let's plug in what we know. The base of this triangle is 16 inches. The height we just found to be 6 inches. Gets me 48. And it's an area, so that would be in inches squared. All right, so that's the Pythagorean theorem. Again, I picked out some kind of tricky problems just because this is something we've definitely been exposed to before. But the Pythagorean theorem, once again, says if ABC is a right triangle, then a squared plus b squared equals c squared. The new thing we're going to introduce today is the converse to the Pythagorean theorem. So we know what a converse is. That's just a theorem backwards. So the converse of this says if a squared plus b squared equals c squared, then it is a right triangle. So at the top there's that converse written out. Again, if a squared plus b squared equals c squared, then ABC is a right triangle. We can also expand this just a little bit further with the Pythagorean inequality theorems, because if we test out a squared plus b squared and they're not equal to c squared, we can make some other generalizations. So if c squared ends up being less than a squared plus b squared, ABC is acute. And you can see that in the picture off to the side. This angle is smaller than 90 degrees, so the side across from it is going to shrink. If c squared is greater than a squared plus b squared, ABC is an obtuse triangle, because if we take that 90-degree angle and we stretch it out to be an obtuse angle, the side across from it is going to get larger. So given some triangle lengths, we're going to classify these triangles. So in order to classify a triangle, we just have to test the relationship between a squared plus b squared and c squared. You get to pick your sides arbitrarily. We just want to make sure that c, our hypotenuse, ends up being our longest side. So in the case of 5, 7, and 9, c would have to be 9, but then a and b, we just get to pick. So we'll say a is 5, b is 7. So a squared plus b squared would be 5 squared plus 7 squared. So 25 plus 49. 74. And then c squared would be 9 squared, which is 81. So we're going to compare those two. 81 is bigger than 74. So since c squared is greater than a squared plus b squared, this triangle would be obtuse. All right, now we're looking at the numbers for b, 6, 8, and 10. Again, your longest side is always going to be c, and then the other two get to be a and b. So a squared plus b squared in this case would be 6 squared plus 8 squared. It's going to be 100. 10 squared is 100. So in this case, c squared is equal to a squared plus b squared. What we know from the Pythagorean theorem, a squared plus b squared equals c squared, is a right triangle. And then you can probably guess that the last one's going to be acute. Let's actually walk through the work though. So my longest side is going to be c. My other two sides get to be a and b. 8 squared plus 9 squared is going to be 145. 10 squared would be 100. C squared is less than a squared plus b squared, so this triangle is acute.